Hey everyone, welcome back. Today's day three of my 30-day FAANG grind, and I'm trying to solve 6 to 10 LeetCode problems daily, breaking each down on video and sharing with all of you on YouTube. I'm Divya, by the way. I've interned at Massachusetts Institute of Technology, where my area of focus was in machine learning and statistics. Currently, I rank at top 0.2% globally on LeetCode, and like most of you, I am preparing for FAANG interviews. If you are on this grind too, you are not alone. We are in it together. Yesterday, we tackled two pointer, and today we are jumping into prefix and suffix-based problems, which is super common in arrays and strings and a favorite theme in fan interviews. We will also sneak in a few sliding window refacers to keep all those patterns sharp. Before we begin, if this video helps you, please give it a like, share with somebody who's prepared, and hit subscribe so we can crack these interviews side by side. Let us go. So this is the problem number 2 for today, which is 152 maximum product subarray on LeetCode. It states that we have been given a subarray that contains both a positive and a negative number, or it can also contain zero. Our objective is to return the maximum product of the subarray in that array. Please take a look at the constraint. And now we will directly go to the dashboard and we will try to investigate and come up with a solution for this problem. All right, so we have been given nums array, and I've taken an example 2023, and our objective is to return the maximum product of this subarray. Okay, so how do we begin? What would be the brute force approach? The brute force approach would be to generate all the subarrays and compute the product of each and every single subarray and return the maximum product. But that would take us to a path of quadratic, right? Something that we cannot afford, and it will be of order of n square, which is something that is beyond our time constraints, correct? All right. So how do we approach this problem optimally? Let us take a look back at something basic. What happens when we multiply two different positive numbers, such as this and this? Their magnitude increases, as you can see, and it will give me a positive number. What happens if I multiply two different negative numbers? Their magnitude increases, and it yields me again a positive number. What happens when you multiply either a positive or a negative number like this with zero? The product will always equates to zero, as in this case. It has phased it, right? If you're a physics fan, then you know what is going on over, right? Composition, decomposition of waves, correct? Now, what happens if we have a positive number and a negative number? In that case, the product will always be negative, correct? This is the central idea of our investigation, and we will use this idea to move ahead. How? There are few cases that might arise. At any arbitrary state in our solution, we might have a very large negative number. As we know, negative is always less than positive, correct? Negative number cannot be really maximum if there are positive numbers, correct? So what do we do with that negative number? We remain hopeful with that negative number. Hopeful, wow, that is a word. Hopeful about what? We remain hopeful that we find another negative number far ahead in the future that will make this a large positive number. As you can see over here, two different negative numbers gives me a large positive number. So when we encounter a negative number, we do not discard it. The product of a negative number, we store it somewhere in our program, and we hope that later in the future we encounter another negative number, which will compose it into a positive number. Perfect. What happens if we are currently, if our product is positive? If currently our product is positive, it is a very good thing for us, because what if the remaining number are positive as well? It will increase sharply, right? The magnitude of it. But what if we encounter something negative later on? All our effort will go down the hill. But hey, before encountering the negative number, before that point, we would have stored the product somewhere, right? All right. But what if our product P faces the evil zero? What happens in that case? In that case, God bless us, because the product will dissolve to zero and all our effort will go in vain. But is that the case? Is that something what will happen? We will look at this specific case of what happens when we take a look at 0 and how we overcome that thing. I will directly take you to the code first, and then we'll come back here and we'll do the dry run. Just remember these three cases that we have discussed, okay? Let us go back to the code. All right, what is going on here? We declare a variable called as maximum product. It is something that we will return at the end. As you can see over here, we are returning maximum product. We are returning maximum product, okay? We declare two different variables, one for the negative product and one for the positive product. Let us come back to diagram over here. I told you, right? What if our current product is negative? This value will be stored in negative product variable. Then I ask you, what will happen if our current value of the product is positive? Where do we store it? That product value will be stored in positive product. Make sense? Then what we do next is we scan through loop, which will take me order of and time complexity, linear, correct? Now, within the loop, the first thing that I do is I start to make a comparison. At every single stage, we have to make two different kind of comparison. The first kind of comparison entails with negative no product, and the second one is directly referred for the positive product. Why do we care about negative product? Since it is always lesser than positive, we care about negative product because we must remain hopeful to encounter something else negative later on, so that it all becomes positive. Okay. And with positive, it is obvious that it will always be positive if it encounters positive yet again. Okay. So what do we do? What do we see here? We see that we are making few comparisons. In fact, three comparisons. We are storing, we are declaring a variable called as current minimum, which is like the current minimum product at this current state. What is the state I'm talking about? The state is defined by the iterator where I'm currently standing. That is called as state in this case, right? So current minimum is the current state where I'm standing. And current minimum means current minimum product at that state. How do we define that? Since the name says it has to be minimum, so we declare this minimum keyword and we make three different comparisons. One with the positive product times the value at that index, negative product times the value at that index, and that number itself. Does this make sense? If not, let me tell you why it will make sense. What is the need of this thing? Assume that this is something which is 0. Okay. Our positive product is 0 over here. So this entire thing will give me 0, correct? Assume negative product over here is some negative number. Okay. It will give me some negative number. And num is some negative number itself. So we just make comparison between these two things. All right. Okay. That did not make a lot of sense. So let me tell you a different way to approach this thing. But before that, let us come back to the next line where we are making a comparison for the current maximum product at that state. Again, we see three different numbers. Nums1, positive product times the magnitude of nums1, negative product times the value at nums5, correct? Okay. So what is going on here? These three things that we are seeing over here, they are very important. Why? Because negative product, this part, it tells us, hey, what if our product is negative, and if I'm encountering a positive number, it will be something of much, much higher negative value, correct? And that will be stored in current minimum. But and that current minimum, it gets updated later on. This negative product, it gets updated later on with current minimum. And when we come back to the loop in the next round, we see over here that this negative product, which was updated with current minimum, which came from here, right? It gave me a really, really high number in the next round. Okay. So that is what we are trying to do over here. Now, after we compute all those two things, we come to the maximum product, which is something that we will return as the output. We make a triple comparison between three different elements, and we store the maximum in the max product. And at the end, we assign current minimum to negative product, and we assign positive product to current maximum. Let us go back to the example, and we'll see how everything is working on here. Maybe a walkthrough will make much more sense. Currently, I'm at this position. This is my positive product, This is my negative product. Initially, both are 1. This is my maximum product over here. Something that will return as an output, which is currently 2. And this is my current minimum, and this is my current maximum. Okay. Let us see what is going on here. When I'm at this point, what do we see? We compare for current minimum. Come back to the code and see. We compare 3 different things, right? We made comparison between 2 times 1, 2 times 1. So the value remains 2. For this as well, it remains 2, correct? In the next case, this is an interesting case, but before we jump to that point, what do? We change our positive product and negative product with current product, current maximum product, and current minimum product, and it will become 2 and 2. As we come back, as we come over here, it will be making a comparison with 0 as well, right? 0 and positive product times 0, negative product times 0, right? So what is the current minimum of this case? It is 0, right? Because all has been dissolved to 0. Similarly, for current maximum product, it will be dissolved to 0. And when you come back to maximum product, it will make a comparison something like this, 2, 0, 0. And it will again yield me 2 because 2 is the maximum. And before we proceed forward, our positive product, it will be changed with current product maximum, and negative product, it will change to current minimum product, right? So they both will dissolve to 0 once again. And once we come back over here, something interesting happens. What is that? We start to make a comparison over here between what? The first element, positive product times the element, negative product times the element. So which is the minimum in this case? The minimum is still 0, all right, but it changes for this case, for current maximum product, which is like the current element, negative product times the current element, positive product times the current element. These two dissolves, it just remains 2. So our current maximum, it will become 2, all right, and our maximum product comparison, it will look something like this. It will be 2, which was the maximum product, minimum product, which is 2, which is 0, and maximum product, which is 2. It will again remain 2. Okay. Now something really interesting happens at the last point. We have 3 over here. So what will happen? Okay. By the way, I forgot to change this thing. Maximum positive product, it will become 2, and negative product, it will remain 0 from here, right? Okay. So what happens next? In the next iteration of the loop, we again make a comparison for the current minimum product at the state when we are at 3. So it will be like 3, negative product times 3, positive product times 3. And for current maximum product, it will happen something like that, similar thing. It will be 3, negative product times 3, and positive product times 3. So what is the value? It will change to 6 from here, right? And when we make a comparison to maximum product, it will be maximum product, which is 2, current minimum product, which is 0, and current maximum product, which is 6. So it will change 2 to 6, correct? Which is something which we can see, 3 to 6. This is the exact subarray product that we will return, okay? So I hope this was really helpful. And one thing that you need to take care of is these comparisons that we're making. I would encourage you to try on your own with multiple examples, and maybe that might make you much more sense. As far as time complexity for this code is concerned, so the time complexity revolves around the lower bound of linear time complexity, and the space complexity is constant. Let us go back to the LeetCode dashboard, and we'll try to submit a solution, and we'll see how it goes. I have already submitted a solution, so I'll just copy and paste my code, and I will run it. This is the exact code. So as you can see, our solutions has been accepted. So yeah, that was all there was for this problem. It was a bit of tricky problem and requires a deep and profound insight into how to make comparisons and what are the cases that can arise. Okay. So yeah, with all that in mind, I hope you understood what